very important role for material plays very important role. So thank you, sir, for the accepting our request. Sir, please you can start presentation, sir.
Okay,
Thank you,
sir. Thank you so much, and it's like a good opportunity for me to join you with the students and the faculty members. And I'm thankful to Dr. Vipin also that he invited me and gave me the chance to share my views. And I choose the topic like engineering materials, properties, and selections for their various applications. So may I share my screen also?
Yeah, rights I've already shared with you. Please kindly go ahead.
Okay, just a minute. Okay.
Yeah.
How it is visible now?
Yeah, it is visible, sir.
Okay. Okay. So let me introduce myself first of all. That myself, Dr. Ranvir Singh Tomar, and I'm faculty here in the Department of Metallurgical and Materials Engineering, which is quite related to the mechanical engineering also. And here in the Punjab Engineering College, that is formerly known as the PEC University of Technology, Chandigarh. And I am here from last, I think, 7 years. My research areas are, as you have told, that this is development of the composite materials, their tribological study and the corrosion behavior. And apart from this, I am working also the formation of nanoparticles also and their properties for the study for the anti-cancer properties. So, but related to the mechanical engineering, I today will discuss about the material, that is engineering materials, and their properties and their selections for the various applications. So first of all, talking about the materials and metallurgy, as you have known, quite related to all the students. And if we will be able to, I have a question that we will be able to discuss with the students also, or they are on the mute side.
At the end of your lecture, we will allow them to, through chat. I'll ask the questions on their behalf then.
Means okay, that's no problem. Actually, I was searching that it is possible to discuss with the students, as this lecture is for the students only. So
yeah,
it will be
exactly.
Great that okay.
But
no
problem. Okay.
I can understand. Okay. So talking about the materials and there are different applications, like in the slides we have the different type of words like casting materials, alloys, deformation. These all are the properties and the process basically are related to the applications or to listen that our requirements for the particular application of a material, and how these property or the materials are basically related to the properties or their selections for a particular applications. When we talk about the material science or about the materials, that is about this is a combination of a heterohedral deformation. That is, it is a combination of the structures of the materials, the properties of the materials, the performance and the process. When we talk about like a scientist or the material scientist, this is basically we talk about the try to relate or correlate the properties of the structure of the materials with the property of the material. But when we are in form of the engineering, then we basically plan to make the our process with the performance. So we when we talk about the engineering or the industry, we basically focus on the performance. But on the base level, when we talk about the research, we basically discuss about the structure property relation of the materials. And these all are related to the characterization or the testing of the materials depending on the requirements, that which type of requirement we have for particular applications. So we have to first of all we have to classify the materials. When we talk about the classification of materials is basically maybe of different types as per the requirement, that we may discuss classify the materials on the basis of their bonds. We can classify the materials on the basis of their properties. We can classify the materials on the basis of our requirements. So here I have classify the materials in a different way, that when we talk about the materials with their structures, like when we have the materials, we use the material basically in the large volumes. And secondly, that the functional materials, which basically we use them in a small volume. So when we talk about the structural materials or the material which we use in the large volumes is basically related to their properties, and we talk generally talking about the mechanical properties like tensiles, toughness, creep, corrosion, fatigue, ductility, and the other properties like hardness, etc. But when we talk about the material which we are the functional materials or the functional properties of the materials where we have the small volume, so we basically about the physical chemical properties of the materials like chemical properties, magnetic properties क्या होंगी, and electrical properties, optical, thermal. So these are the properties which are basically related to the small volume of the materials. So starting with this, so when we talk about like chemical mechanical properties, so these properties are like strength, toughness, stiffness, and your hardness. So these properties are basically related to the mechanical properties, or the comes with the category with the mechanicals. And these applications of these properties are like we use in the machineries and the load bearing structures where we have to take the materials as a load for the load bearing capacity. And when we talk about the chemical properties, so chemical properties are about the corrosion resistance properties or the materials, how the materials perform under some particular environments like the chemical or the sunlights or in the presence of the water. So these all comes with the chemical properties or the category under the chemical sections. So their applications are in the chemical plants, power plants, marine structures, and the outdoor structures. And finally, when we talk about the physical properties, these are related to like density, thermal conductivity, electrical conductivity, or the magnetic properties. So optical properties are also the part of the physical metallurgy. So depending on the property of the material, there is specific requirements or the specific applications in the different area of engineering are related to. As when we talk about the densities, they are quite directly related to the aerospace, outer space of the reciprocating or the rotating machines. But when we talk about the thermal conductivity, they are related to the power transmissions. And magnetic properties are sometimes like electrical and the machineries, or sometimes of in the electronics also. So when we talk about the materials, which type of materials we are using, we basically first of all think that what is our requirement, what is our application for particular material or the component. So on the basis of that, we will focus that on which property we are going to work with. Like with the chemical property, we have to prefer with the chemical properties, or we have to prefer with the mechanical properties or physical. There may be combination of both the threes and the others properties, but the main choice will be depend on the property which is required for a particular application. We will discuss it in the next slides. So first of all, we will talk about the materials. So as all are quite aware with the materials that we have basically two or three different type of materials like metals and non-metals. When we talk about the non-metals and the non-metals are like ceramics and the plastics. So when we are talking about these type of materials, this depends on which type of bonding is there. So as we know that we have the different type of bonds like the primary bonds and the secondary bonds. When we talk about the primary bonds, these are related to like your ionic bonds, your covalent bond, your metallic bonds. But when we talk about the weak bonds, these are related secondary bonds. These are the weak bonds, and they're like hydrogen bonds and the van der Waals bonds. So depending on the bondings, these property of the materials is basically related to the bonding of the materials. So atomic structure is quite related to the interaction of the atoms. On the basis of these, the bonds like single bond, double bonds, primary bonds, or the secondary bonds, we can classify them, or we can use justify them in the case of like plastic materials, metals, or ceramics. So when we talk about the composites is basically combination of two or three or more than, we can say more than of two materials, which basically used to improve or enhance the property of the base materials. For example, if we talk about the composite materials, there are two things. That first one is the composite material, and second one is the alloy. Alloy have the same property, same type of definition. You can say that in the alloy also we have two or more than two type of materials, the combination of two or two of the materials. But in the composites, we have the combination of two or more type of materials. So there is a thing that we should be clear with the composites and the alloys. So when we talk about the alloys, we can say that alloy is basically a combination of materials or different type of materials, and that composition is homogeneous. Homogeneous means they are completely mixed with each other and they will make a new phase of a material. But when we talk about, for example, brass, but when we talk about the composites is basically combination of two or more three type of materials maybe there, but all the components, all the constituents that are the part of the composite will have their physical and chemical presence of the in between the materials also. Means they will provide or they will develop a new material, but they are physically or chemically distinguishable within the materials. So like if I'm talking about, I'm taking the two or three type of materials to make them a composite A, B and C. So after making a composite, I will be able to define that where is A, where is B and where is C. If we talk about a common example, that like in a pillar that we use when we make the buildings or the bridges. So the pillar which we use in our house or at our home or buildings, that is a combination of three or four type of materials. Like one is your iron rods, that is we call in Hindi like saria. Second is sand. Then we use some stones, that is, and the cement. So when we talk about the combination of these pillars, one pillar consists your iron rod, your stones, your sand, and the ceramics. So you can find out these part where is the your stones are present, where is your the roads are present, where the cement is present. So these is basically the property of a composite that you can distinguish them physically or chemically, the presence or the of the components. So we can define these composite and the alloys like this. Okay. So the most important thing when we started with the materials, that was about the bonding. So all the properties and the materials and the composite, their requirements are related to the atoms. This is the smallest thing that we can discuss. And when we talk about the atoms are basically uh, when combined with each other, means comes together and make a bond. So on the basis of the bonding, they basically show the two different type of materials that they may, with the using the bonds, they may form in the form of the crystal structures, or they may behave like electromagnetic property also may be there. So structure, by joining the structure one by one, like in the materials, or we have the crystalline structure or the non-crystalline structure polymorphous. On the basis of that, we make the microstructures, and by combining these at the large scale, we go for the components. So if I need a property of a particular component, like there are so different process like that may be used by the casting, metal forming, welding, powder processing, all the parts of the components. So if I want to improve or change the property of a component, then I have to improve or change the microstructure of the materials. And if I want to improve or change in the microstructures, then obviously I will work on the structure of the materials. And if I am going to structure or crystal structure of the materials, that means I am working with the change in the atomic bonding of the material. So basically all the things start with the change in the bond of the between the atoms. So when there is a change in the bonds between the atoms, there will be change in the crystal structures. When there is change in the crystal structure, it will basically change in the microstructures, and finally it will be related to the component. So if I am saying that I am increasing the hardness of the component, I am increasing the toughness of the component, tensile strength of the component. So basically I am going to change in the atomic bondings, but it is not quite possible or quite easy to us to study all the time that what is the change in the atom or the bonding scale. So we try to relate these property of the components with the microstructure, as it is on the micro level. So atoms are at the angstrom level, so it is quite easy for us to work or study the change in the microstructures with respect to the components. So this is how we fix our requirements, that what will be the change in the property, what is the requirement for the change in the property, and on the basis of that we will try to change in the microstructures to improve or enhance the properties of the component or the materials. So now we are talking about the properties of the materials. So basically we can describe or divide the properties of the materials in the two different ways. First is the fundamental parameters and second one is the ranking parameters. When we talk about the fundamental parameters, so these are the properties which are basically directly related to the property of metal, like the mechanical property or your the property required for the particular application, like you need resistivity, you need stiffness, you need hardness, or the brittleness or ductility. All these are basically how, like, I need a composite that should have the property of like 100 HRC or 50 HRC for a particular applications. So this is the fundamental parameters that we use for the property of materials. But when we talk about the ranking parameters, ranking parameter is basically not about to requirement of a property. It is about the selection of a materials. If like I have two materials and I need for a particular application, I need a material that have the hardness, that should have the hardness of 50 HRC. But for a particular applications, I have the similar five type of materials or three type of materials which have the hardness of 50 or around 50 HRC. But then I will go for the selection of Engg Materials. It is quite easy to understand, like I want to purchase a mobile. My requirement is like there should be a camera of 50 megapixels. So this is the fundamental parameters for the property required for my applications, that mobile should have the 50 megapixel camera. This is my requirement. But when I am going to ranking the parameters, so I will go into market, search about the mobiles which have the camera with the 50 micro. Then what will I will go कि अगर मेरे पास 4 मोबाइल्स हैं जिनके पास 50 मेगापिक्सल कैमरा है, then I will try to get the other properties, or I will try to understand the other properties that which are also beneficial for me. Then I will choose, अच्छा इसमें refresh rate किसका ज़्यादा है, प्रोसेसर किसका अच्छा है, प्राइस किसका अच्छा है. So these are the ranking parameters which basically help us to choose or design a materials during the selection of a particular applications. Now, so when we go for the motivations, what are the motivations for the selection of materials? So there are two different things. That first one is the development of a new materials. This now I'm talking about the selections of material for a particular applications. So this is about the development of new materials, and second one is the improvement in the existing product. These are the two things that basically help us to the situations of necessity of the materials. So when we talk about the new product development, so new product development is basically about the expectation of the customers. Okay? What the customer expect from you or that particular kind of product. Second one, meet the needs of the customers. Second, the beat the competition of the market. So you have to make a new product, or you have to, when you are trying to launch a product or discuss it, so we have to basically compete the market also. Next, third point is the offer either better performance, more features, or both. When you are in a market, that basically you have to give the three options. First, that meet the needs of the customers. Second, beat the competition to market, and third one is I offer either better performance or more features. Fourth one is to be perceived to offer value for the money in terms of balance of the cost. This is quite important point, that when you are talking about the performance, when you're talking about the competition in the market, when you're talking about the needs of the market, you have to focus on the cost of the materials also. So there are the things that the legislations for safer when we are talking about the development of a new product. So you have to be like environment friendly and other things, and you have to be take the risk and the opportunity with the new technology. So apart from this, when a new product, it is a job of material engineering, as we are going to select a material for a particular new technology, so it will be our responsibility that we try to evaluate the new materials, their properties, their performance in a particular applications that may be suitable for the to improve the properties or performance in comparative to the existing materials. So like when we are trying to produce a launch a new material, so that is basically four major factors are with that. First one is like we will try to design a material, we will try make a design for that particular material. Second, then we will talk about the materials that will be required for that. Then we will talk about the manufacturing, or you can say that labor work, and then overhead charges that may be basically related to the your expenses, your salary of your persons that work in the industries and all. But these this is the real cost, like 5% cost is used for design, 50% for the materials, 15% for labors, and overhead charges are around 30%. But the influence of these in the cost of material is like if your design is very good and you are you have make a solid design that have the lowest manufacturing defects, then it will influence the cost by 70%. Materials that have the 50%, it will influence the cost by 20%. Labor and overhead charges are like 5%. So it is important to work with the design and the materials to get a better material for a particular application for the suggestions or the selections of the materials. So next thing that will be discussed about the selection of materials on the basis of their cost. So when we as I told that if I am in market for to purchase a mobile and that should have a 50 megapixel camera, so when I'm in market I will choose the other properties, and as I earlier told that ranking parameters, I will set my ranking parameters, I will choose the 3 different mobiles, and finally I will go with the cost, that what is the cost of the material and which is the at lower cost with the same properties, and that will help me to select a materials for a particular applications or as per my requirement. So the cost is a major factor that basically help us for the selection in a different selections for a different applications. So when we are going to buy a product or to launch a product or the materials, this is basically performance oriented. We choose the materials on the basis of with the 2 types. First one is performance oriented products, and second one is cost oriented products. Performance oriented products is like when we don't think about the price, like people are generally when we talking about the mobiles, they are go for with the iPhones. Okay, cost doesn't matter but the performance matters. But when we talk about the cost oriented products, so these are the products which basically help us for our requirements for a particular applications, then in a particular cost. Okay, I'm getting the matrix. So this is the value for money. When we talk about the cost, there is a thing that is value for money. So we talk about the things that what is the value and the cost. So there are 2 things. Value is basically the extent to which the appropriate performance criteria is satisfied, means you have buy or purchase a material and finally you got the things that this is as per our requirements, and you have used that as the material as per your cost. The cost is what you have paid basically for a particular level of value. So when we talk about the selection of materials, we focus on the values of the materials. So these are the some factors that are basically responsible for to improve for the cost of the materials. So this is like the variable cost are there, like cost of the basic material, cost of the manufacturer, and there are some fixed cost like factory overheads, administration, market sales, and then you talk about the manufacturer of profits. So this is the part of the purchase profit, and second one is your cost of ownership, that the maintenance, repair, insurance, automation. So all these things will basically be responsible for the total cost of the consumers that will be you have to pay or for a particular materials. So there are some financial risks also. I will try to conclude my PPT in next 5 minutes. Okay. So financial risk also with the new materials, new products. So this risk can be reduced when you are trying to launch a materials. So instead of launching a new material, we basically give the updates of the materials at a regular intervals. This is called as the incremental innovations. So this basically help us to make a lower financial risk for our new product. Okay, there is a supply and demand which basically help us to fix the rates of this is quite related. So coming to the next, like when we are talking about the cost of the compositions or like metallurgical complexity, I will take an example that for a particular aluminum alloys, like if I talk about the M1 alloy that is 7010 T6, rate is like 500 per kg. If I talk about the another aluminum alloy that is 5083, that is 385. But if I talk about the aluminum lithium alloy, that is around 2500 per kg. So there are several factors which basically affect the cost, like degree of purity, आपके material कितना pure है. Second, cost of the जो alloying elements आप add कर रहे हैं उनकी cost कितनी है. Practical difficulties allowing in the allowing elements to tight its specifications, and the scales of the alloy use, इसका use कितना है, and the rejection rate. These are the some factors which basically help us to fix the rate of a particular materials. Okay, so apart from this value added costs, these are the some points. Now when we talk about the selection of a material for a particular anticipated services, these are the two things that we discuss when we talk about the designing. So designing is based on the property of the materials and the mode of failure of services. These are the two important factors which basically help us to find out that what is the requirement of the properties. What is, when we are designing a material, we have to focus the properties of materials कि material की अपनी properties क्या हैं, and what is the mode of failure. Like if the material is failing in a conditions, in a particular conditions, like due to the brittleness, so that means there is a chance that we should use a material that should have the lower hardness, which show the ductility also. So it will decrease the rate of failure of the material. So there are the designing should be like the property of the material should be same, but their mode of failure can be avoided for a longer period. But it is almost impossible to get a combination of properties by using only one materials. So we have to compromise it. We have to fix that it is not possible always that one material complete our all the requirements. So we basically try to get the different materials like in the composite materials or the alloying elements, which basically importance of composite material or alloying elements are like we can tailor the properties of the materials as per our requirements. So the material selection always involves the act of compromise, like selection on the basis of the properties that basically conflict the technical and commercial economical consideration, and it is basically depends on the service requirements also. Okay. When we talk about the engineers, so we have sometimes to move in the areas we basically where we don't have some past experience of failure of materials, and or we have to incomplete knowledge as well as the data. So this is basically important point. So we have to try it or formulate the things that reduce the rate of failure of the materials. So when we talk about the causes of failures in the materials, so there are different type of causes of failures, like that may be due to the error in the design, that may be inherent properly selected materials, there may be a defect due to the during the fabrications, there may be deteriorations in the services. So these basically these are the factors which are basically responsible for the selection of materials. So the selection of materials should be that when you are trying to make a design, so it will completely match with the design of the materials, like in the form of the castings, in the form of the designing, wiring. So properties of material should be like in our requirements. So these are some details like manufacturing defects. When we are talking about poor selection of materials, it is basically 40% causes of the failure of materials when our selection of material is not as per the requirements or the properties of the materials. So it is a major factor that is basically responsible for the failure of the materials. So manufacturing defects, this is also an important parameters or causes of failures, which basically due to the fabrication imperfections or the treatments during the manufacturing. So design deficiencies are also the parts, and the exceeding design limits, like if we have fixed the parameters of for the materials that working for the working conditions, but if it is exceeding that, so there is a chance of failure of the materials. Okay, so failure analysis, when we are talking about the failure of the materials, some failure of materials basically help us to find out the problems related to that particular materials and to improve the performance of a material in a particular applications. So depending on the failure analysis, we can fix, is there a need of change in the design of materials? Is there a need of change in the material? Or is there a need change in the manufacturing process, or as well as the requirements for the particular applications? So
Ranvir sir, time is running up. So thank you very much. Thank you very much for delivering a nice, wonderful lecture on the material properties selection and its cost analysis. Thank you very much for being with us, for delivering such a nice lecture. And
sure. Thank you, sir. Thank
for
you so
that
much.
token of delivering lecture, we will this is an appreciation certificate we will provide you on the behalf of our SAGE group. So please accept it.
Thank you, sir. Thank you so much. Thank you, sir. Okay.